meeting is being recorded.
So I'll be taking you through only analytical questions, and today I have shared an Excel file in the respective WhatsApp group. That was already shared also. In case you do not have the Excel file, you can at least download and then keep it ready with you, and that can be used during the exam, during your real-time project work time, during your project work also. All right. So now the purpose is to face certain questions. The first question: what is the area contained within -1 and +2 standard deviation? So anyone, can you answer this? Do you think you can answer this question? Do you think you can answer this question? Come on, let us not waste time today, because we have only limited time.
0.8581.
0.8581 is the correct answer actually. But how to do it? How will you do it? That's very important, right? So we all know, but now I will tell you the approximate method, because you don't have to use Minitab or don't have to use any software. Because we know -1 + 1, 68%, isn't it? -1 + 1, 68%. And let us draw the graph and try to understand. So here is your normal distribution curve. Center point is 0. This is -1. And this is +1. And now one of you please tell me what will be the area inside? 68%. Am I right?
Correct.
Yes, sir.
So half of which will be 0.34. I mean 34%. This is also 34%. But now they are asking us to find out the area between -1 and +2. So draw one more. So this point will be 2. Now somehow you should be able to find out this area also. Now how to find out this area? What is the method you can use? If I assume -2, yeah, if I assume -2 here, the area between -2 and +2 will be how much? 95.45. I'm just taking only approximate. So what is half of 95? 47.5.
Right.
Correct?
Correct.
Out of the 47.5, 34 is occupied up to this. So remaining will be 13.5. So 34, 13.5. Is this coming to 0.8185? Am I right?
Yes.
All of you got the answer. How I worked out? I have not used any calculator. Only just a simple calculation in the mind. That's all. You can always use Minitab to perfectly handle any situation. So all of you, are you comfortable using Minitab? Do you really have Minitab installed in your laptop or something? Shall we use Minitab also?
Yes, sir.
Yes, sir.
Okay, if you have Minitab, we can see the same problem.
Yeah.
How can do it in Minitab? Let the Minitab open for me, and meanwhile let us do one more question. And now go through the question and try to understand, try to answer. The final exam score of an institute has a mean score of 74 and a standard deviation of 6.8. The exam score follows a normal distribution. What is the distribution for the mean exam score of 50 students? So do you understand the question? Are we talking about individual score or average score?
Average. Average score.
So definitely the answer is no. Option is A or B only. X means individual observation. X bar means mean, mean value. And N means normally distributed. Normally distributed means the parameters are mean and standard deviation. Mean is 74, only standard deviation is changing. Now, what is the distribution for the mean exam score of 50 students? Right? A school, an institute has a mean of 74, standard deviation of 6.8. When I say institute average and institute standard deviation, they are called population parameters. Am I right?
Right.
And now this is a sample of 50. Now what will be the standard deviation of the sample? What will be the standard deviation of the sample? And moreover, we want to understand how the mean score of the 50 students will vary. So, please all of you listen very carefully. We have taken a group of 50 students, right? So, the average of the 50 student is, okay, the average of the 50 students will be, let us say, X bar. Let us say X bar. And this, and now the standard deviation of the distribution of the average. Standard deviation of the distribution of the average is known as standard error of mean. Do you know what is standard error of mean? If I take continuous sample of 50 students, then I will have so many averages, right? X1 bar and then X2 bar. Similarly, no, it will keep on moving. So many averages will be there. All of you, can you understand X1, X2, X3? No, every number here is an average. Every number here is an average. That means I'm talking about distribution of averages. What am I talking about? Distribution of averages, not the distribution of individual marks. Do you get my point? Suppose if you are a class teacher, you will look at every student mark. Am I right? Yes or no?
Yes, sir. Yeah.
Suppose if you are head of the institution, will you look at every student's mark?
No.
No. You will obviously ask for the what is the average mark of every class. You might have 10 classes. Class number 1, what is the average? Class number 2, what is the average? Class number 3, what is the average? Now you have 10 classes. So how many averages you will have?
10.
10
10
averages. So this is called distribution of averages. This is called distribution of averages. Now we are also talking about the distribution of averages only. The beauty of distribution of averages is the average, the average of all the subgroups will equal the population average, will be very close to the population average. That is why you are seeing, the same thing here, 74 and 74. And the standard error of the mean is nothing but the population standard deviation divided by square root of n. We have discussed this already in the class also. I do not know whether you remember or not. So the population standard deviation is how much? 6.8. I'm sorry. And n is here 50. If you work out this calculation, that will come to 0.9617. So what is the correct answer? What is the correct answer?
The B1. It's version.
B is
74
the correct answer. Right? B means
Option B.
the average mark is normally distributed. And the average of the average will appear in the center. See here, average of the average will appear in the center. This will be equal to the population average. And the standard deviation of this distribution will be equal to standard error of mean, which can be calculated using sigma by root of n. And this knowledge is called central limit theorem. What is it called? Central limit theorem. What is this called? Central limit theorem. So we have solved this problem with this particular thing. Now let me take you to Minitab, because Minitab is now ready. All of you, can you see my Minitab screen?
Yes, sir.
Yeah. So see here, there is a graph button. Go there. Probability distribution plot. Then there is view probability. That is graph, probability distribution plot, view probability, then okay. And now see here, Normal, choose normal. When I give mean equal to 0, standard deviation equal to 1, what is this called? Is it called a normal distribution or standard normal distribution? Come on, please.
Normal.
Normal.
Normal distribution means there will be an average value, there will be a standard deviation value. But here, how much is the average?
0.
0.
If you assume average equal to 0, standard deviation equal to 1, now it should be called as standard normal distribution. That is the difference. Normal distribution means always it will have some average, some standard deviation. If you transform the average to 0 and standard deviation to 1, it will now be known as standard normal distribution. Is it clear to all of you? So now,
Yes, sir.
now go to shaded area. Now I want to know the area between 2 points. So choose the last one, area between 2 points. And I am going to declare the points. In your question, see, I selected X, I selected the last one. In your question, what is the area you wanted? What are the 2 points? 1 point is on the left side. What is the value? -1, right?
Yes. Yes.
So
Second
right
value
side-
is +2.
Right side, what is the point?
+2.
+2.
So you give these two values, and now Minitab is giving a curve. How much is the area between the 2 point -1 and +2?
0.8186.
So is it easy to use in Minitab?
Yes, sir.
Yes or no?
Yes, sir.
So let us do it again. Can you tell me which button I should press now?
So go to graph,
Graph and then
probability
distribution plot.
distribution plot,
probability distribution plot, then
P probability.
view probability, and then
Okay.
here which distribution I should choose first of all? So
Normal.
many distributions are there. Which one I should choose?
Normal.
Normal.
Then
Mean
Mean is equal to 0, standard
is
deviation 1.
I have to type make mean equal to 0, standard deviation equal to 1. Then I should go to
Shaded area.
shaded area. Then choose between 2 points,
Middle.
area between 2 points,
2 points.
and ensure you have taken the X value here. Now you type the value. Any value you type, answer will come. Suppose if a question comes, what is the area between -1.25, right? -1.25 and +2.75. Now it is very difficult to think, isn't it? All of you? It's tough or easy?
Tough, sir.
It's
Yeah.
bit up.
Manual.
So, but once you know how to use this template, you can handle thousands of questions. If I give okay, the answer will come. Can you see?
Yes, sir.
Even you can write, any exam, any external certifying agency, if you are writing an exam for some other reason, if you are going for some exam in Six Sigma, and you can solve any problem. Any question comes, between any 2 points, you can do it in the same method. So shaded area. Now let me give a point here and let me check whether you people can answer this. What will be the area now between -3 and +3?
99 points.
99. sir.
99.7.
99.75.
Can you see here the answer 99.73? Is it visible?
Yes.
That means you learned well, right? So one specific problem, but now you are ready to face thousands of questions similar to this. Am I right or not? Any two value I give, 0.5 this side, 0.75 this side. Will you be able to find out the area between the 2 points?
Yes.
Okay. So I'm not going to explain the similar thing further. So now you understood. Now let us move on to the other questions. So this one we have done. And now tell me whether you can answer this question. A random variable is normally distributed with mean 80 and standard deviation 2, where X is the mark scored by the student. What is the probability that his score will be between 75 and 85? Do you think you can handle this case using Minitab?
Yes, sir.
Okay. So please remember the number. I will do it in Minitab for all of you. Please remember the number. What is the mean? 80. Standard deviation is 2. And so I'm just sharing Minitab now.
0.9876.
Oh, somebody has worked it out. So graph, probability distribution plot. I should choose view probability. I'm coming here. See now, what is your mean? You said, what is your mean?
80.
80.
Standard deviation 2. 2.
Please, all of you understand, a real-time problem will always have a mean value, will always have a standard deviation. This is how your students have performed, right? Now, shaded area. I want the probability for a student to score between
75 to 85.
so 75 left side and right side. How much I should type?
85.
That's all. What is the probability?
98.
98.76.
So, if the class average is 80, standard deviation is 2, 98% chance is there for any student to score between 75 and 85. All of you, do you understand how we worked out this problem?
Yes, sir.
Very good. So,
Sir,
but
once back, sir, back to the graph.
one more time.
One step back to the graph. Why? Because I was on Minitab.
Oh, you are also in Minitab, huh?
Yeah, just back to the.
Yeah. Is it the graph you want to see?
No, sir. Back one step, sir.
Oh, you want me to show the steps again, right? So let one of you please guide me. Where should I go now? Graph, right?
Graph.
Then,
Probability distribution plot
okay.
and view probability.
View probability, okay.
Then
Now
mean 80.
Normal, mean 80.
Normal distribution, mean 80. Standard deviation 2.
Very good. Then,
Shaded area.
shaded area,
Probability.
X here and middle. The area should be middle. Between 2 points, no middle.
Okay.
So now here I should type 75 and here I should type 85. So
Okay.
any mark you can type. Suppose I want to know the possibility for a student to score between 80 and 82. Can you tell me
Okay.
what will be the chance for a student to score between 80 and 82? It will be very less. How much it is?
Okay.
34%. Am I right?
Okay.
Probability distribution plot, view probability. Now I am going to shaded area. I am choosing right tile. Now, what is the chance for a student to score above 90? Can we check this? Is my options correct? Selection correct?
Yes, sir.
Yes.
So I'm giving okay. So what is the probability?
Infinity, sir.
Very, very low. You see here, 2.86 into 10 to the power of some minus is coming. Very low.
-7.
Yeah. Okay. 10 to the power of -7. So you see very, very low chance. All of it, you understand why the probability has gone below? Because the chance is very low.
Because the standard deviation is also 2, sir, and mean is 80.
Yes.
So huge differences.
Very good. Very good. All right. See, I really want to know, suggest all of you don't feel afraid of seeing all these analytical questions. Here, what is more than the understanding about the subject, your ability to use these kind of tools, particularly Minitab and all those things will make a big difference. Otherwise, working out all this problem will be manually will be very laborious. Am I correct or not? Right. So now, hope you all can see my screen and try to answer this question. Find the quartile 3 in a distribution which is normally distributed with a mean of 80 and standard deviation of. And why all of you switched off the video? Because the questions are becoming tough. Is it so? Now only you all should be very active. Right. So again, I come back to Minitab because the problem is once again complex. So first of all, tell me what is the meaning of quartile 3? Can you tell me?
It's the right hand side.
Right hand side area will be?
Yeah.
Right hand side area will be 25%. Left hand side area will be?
75%.
75%. The definition of quartile 3 is it is the point to the right of which you will have 25% of the data. To the left of which you will have 75% of the data. So with this knowledge, we are going to solve the problem. See here, graph, probability distribution plot, view probability, okay. And look here, I am taking the same mean and standard deviation. Can you see here, 80 and 2?
Yes.
Now go to standard area. Quartile 3 means right side area will be how much?
Right tail. 25.
25. So choose probability, choose right side area, put 25 here, 0.25. 25 means 0.25. Now Minitab will throw the value. What is the value?
81.35.
Quartile 3 is 81.35. You want to find out quartile 2, then how will you work out? Instead of giving 0.25,
0.50.
0.5. If you want quartile 1,
0.25.
0.75.
0.75. Right side area is 0.75. All of you are with me?
Yes, sir.
But all these problem definitely requires Minitab. Without Minitab also you can do, but you should be an extraordinary black belt.
Sir, recording will be provided, sir?
Yeah, it will be provided. That is why I'm recording.
Okay. Thank you. Thank you very much.
But you now be attentive. Otherwise, recording also cannot help you.
No, why? Because
Recording will be provided. Recording will be provided.
okay, sir. Thank you.
So again, I'm going to the slide. And now this is a theoretical question, but all of you have, one of you, can you read out?
According to central limit theorem, regardless of the population from which data is drawn, the sampling distribution of the mean will be normally distributed.
So all of you, do you understand what is this telling? According to central limit theorem, regardless of the population, let the population be anything. Let the population follow any distribution.
That's correct.
Let the population follow any distribution, but the sampling distribution of the mean. What are they telling?
Always correct.
Always correct.
Sampling
Always
means you are taking multiple sample. Please understand. Sampling means you are taking multiple sample. Then the mean value will be normally distributed. And now you have some option. Always correct, always incorrect, conditionally correct, and none. If you read the central limit theorem, then you will realize this theorem will be true only when the number of sample is sufficient. Do you understand what I'm telling?
Once again, sir, can you explain it?
See, what central limit theorem is telling is the distribution of the mean will be normal always. Only requirement is you should have sufficient number of samples. Your sample size must be sufficient. So let us take the same situation. There is a school or a college. There are 20 departments or 20 sections. How many sections?
20.
20 sections. Now every section will have an average. Am I right? Every
Yes, sir.
section will have an average. Now I calculate average from every class. Now I have 20 average. I am trying to visualize all the 20 averages. Now central limit theorem is telling this visualized graph will definitely be normal. only condition is the number of students in the class, in every class, should be sufficient. If you have only 2 students in a class, that's the time central limit
Thank you.
theorem may fail. It may sometimes succeed with the sample size of 2 also. But if there is a problem, if your mean is not following normal distribution, you can make it follow normal distribution just by increasing the sample size. So the correct answer to the question is conditionally correct. All of you understand? Most of the time in our workplace, we are collecting data in subgroup. Am I correct?
Yes, sir.
We take 3 samples, 4 samples, 5 samples together. And then we take decision based on the average. Why are you looking at the average? Why are you not looking at the individual value? Because the tendency of the average to follow normal distribution is very, very high. Agree? Agreed or not?
Yes, yes.
The tendency of the average to follow the bell curve is very, very high. Only dependency is the sample size. That is why I am choosing option C.
Right.
Clear? Conditionality. Now hereafter all the questions will be easier. You have crossed, all the challenging questions. Now, will you be able to solve this problem? An extrusion die is used to produce aluminum rods. The diameter is a critical quality characteristic. Specifications are 100 plus or minus 0.5. So what is USL?
10.5.
100.5.
100.5, not 10.5. And LSL is
100.5.
99.5.
19.5.
99.5.
Oh, question keeps on changing. Yeah. 100 plus or minus. And the process average is 100.31. And the estimated standard deviation is 0.05. Compute CP. Will you be able to calculate this? Yes or no?
Yes, sir.
So how will you calculate? Can you please calculate and find out the answer? Do you have any calculator with you? Do you have any calculator with you?
3.33.
3.33. Very good. Let me check. Right. Fantastic. So I think you used the sigma level calculator. Am I right? Marakumar, right?
Yes, sir. Yeah.
Very good. So I'm going to show the sigma level calculator to all the participants here. All of you, can you see my latest sigma level calculator? I keep updating this calculator. So I'm adding problems. So whatever any improvement I'm doing, the latest calculator can show you, right? So CPCPK, I come here. And now tell me, oh, everything is already pre-filled. Can you see that, all of you? So let me remove it and type it for you. So what is the upper specs? Tell me.
100.5.
And lower spec?
99.0.
99.5.
What is the process average?
100.31.
100.31.
Standard deviation?
0.05.
0.05.
3.33. This is the smart way of answering the questions. Little effort is required to familiarize yourself with the sigma level calculator given by me. Similarly, you should also be comfortable to use the Minitab option. Then you can handle hundreds of questions. Even if all the questions are similar to this, you will be able to answer all the questions correctly.
Sir, in Minitab, we can able to do all this, sir.
Yeah, in Minitab, you want to do the same thing, huh?
If possible, can you show?
In Minitab, if you want the CPCPK value, you not only need the process mean and process standard deviation, you also require subgroup average.
Yes.
What do you require?
Subgroup average.
Subgroup, subgroup number, subgroup size. If the subgroup size is required, then we can do it in Minitab. So
Okay.
I don't think subgroup size is given here. Straight away, they have given only average and standard deviation. So if data is available straight away, we can feed in Minitab. But importantly, subgroup size should be known, right? But here straight away, standard deviation is given. So when I open the Minitab, I will see whether without giving subgroup size, whether it can work it out or not. All right. So I think it is an easy task for all of you.
Yes.
Unless and until you agree it is easy, no, exam is not going to be easy for you. Isn't it? So if it is easy, now that we are solving, with the help of calculator, is it still looking tough? Just substitute, isn't it? You substitute and then you get the answer. That's all. And now see here again another problem. And who is going to read out little louder? Your voice should be no louder than me. One of-
Desktop are being inspected to check whether the following components are functional.
Hmm.
The RAM, motherboard, screen, hard disk, Bluetooth, and memory slot.
Very
There are
good.
1,000 laptops are inspected. Out of that, 238 defects are observed. Considering the collected data as long term, what is the short term
Easy test.
standard? Yeah.
Very good. So now, do you think you can find out the ZST in this case?
Yes.
So RK
Yes,
sir
sir.
should have taught you, right?
Yeah, yeah.
Yes, sir.
So
Yes,
please
sir.
substitute all these known values. What
Answer is 3.25.
Yeah,
3.25.
3.25. Yeah. Yes, 3.25 is the correct answer. So what are the values? What are the details you will be using? What is the opportunity for error here?
6.
6.
Very good, 6. And the sample size 1000.
1,000.
Number of defects 238.
230.
Now you fill up this detail. Straight away DPMO will come. ZST will also come, right?
Yes.
Hope everyone is clear and comfortable with this question. Now the dimension of a particular part should be between 125 mm and 130 mm. An operator collected a sample of 100 parts. Process average is 126 and process variance is 0.25. Compute ZLT and compute ZST. Will you be able to work it out? Any one of you? Can you work out? Please tell me yes or no. We need to move on. Maximum we can stay another 15 minutes. So we have to see all these questions.
Yes, sir.
Very good. And anybody, will you be, can you just give a demo of how to solve this question? I will allow you to share the screen. Any one of you? Yeah, screen sharing is already enabled. So I stopped sharing. Any one of you here, will you be able to share your Excel file and solve this problem? I am ready to give the input data. Anybody or nobody?
Yeah. Let me share my screen.
Yeah, please. So please share the screen. I will read the question for you one more time. The dimension should be between 125 and 130.
Yeah. 1 second. I'm sharing.
All these questions in the form of recordings I have already shared. If you have gone through it, then understanding this will be much easier. Yeah. Marakumar has shared the screen.
So
Oh,
should-
very good. Now we need ZST.
Right.
Yes. The dimension of a part should be between 125 and 130. That means USL is 130, LSL is 125. That is given. Now the process average is 126.
Right.
Variance is 0.25. How will you convert variance into standard deviation?
Square root of.
That's all. By taking the square root. All of you, can you see? So what is the ZST? ZST is 3.5 and so
Right.
ZLT is?
2.
I am not able to actually make out anything here since I don't know whether you people are feeling confident or losing confidence by seeing all the questions.
Feeling confident.
Is that your confidences are going up or confidences are going down?
Going up.
But I am not able to feel anything because I really, unless and until then you people have to tell me for every question. All right, thank you. Thank you, Madasami. We can, not Madasami, Madakumar. All right. I will proceed with the thing. So next question. So a KPO, process reimbursement received for their customer. The time to process a refund claim is 30 minutes. And the customer expect the invoices to be processed between 25 and 30 minutes. So what is 25 and what is 35 here?
LSL USL, sir.
LSL, USL, very good. And now the same thing, right? The USL, LSL is available, but data is given. You can see that data also in our Excel file. It will be given. Such questions will come with the data, or otherwise you can find the data here. You see here. Where is the data refund? You can just go here. Can you see refund here?
Yes.
Yes.
So now once this kind of data is given to you, you may require the summary of it, isn't it? Summary means average of all this data.
You have to calculate standard deviation mean.
That's all. Similarly, you need to calculate the standard deviation of all these data. Now these two, with these two value, you will be able to calculate ZST. Am I correct? Yes or no?
Yes, yes.
Mean is here, standard deviation is here. So should I also do the calculation for ZST? So come here, sigma level calculator. So I'm just bringing this, somebody is here. So mean is equal to, this is the mean, right? And standard deviation is equal to, this is the standard deviation. Now please tell me what is the LSL, USL? LSL is?
25 to 35.
Oh God, 25 to 35. So now what is the,
Minus 0.53 to 0.97.
what is the ZST?
0.97.
0.97. That is the correct answer also. All of you understand how I handled this particular situation? I am losing confidence now, no, with all of you. So now, laptops are being inspected to check whether the following components are functional. RAM, motherboard, screen, hard disk, Bluetooth, and memory slot. I think this problem, we have done it already, right? No, but this is a similar problem. 1, 2, 3, 4, 5, and 6. Opportunities for error is 6. How many laptops inspected? 500. How many defects reported? 190. So how to solve this problem?
Yeah, answer.
7.
Sample and OFE calculation.
That's all.
That is 3.25. Yes.
Very good. Thank you.
7.
3.25.
Now this question. In a MSA study based on variance, gauge R&R is 0.5, total variation is 0.6. Find the part-to-part variation. Please all of you understand. Total variation is always equal to part-to-part variation plus measurement variation. Are you listening me?
Yes.
Total variation equal to
Part-to-part
part
variation.
variation plus
Measurement
measurement
variation.
variation. Now what is given? Total variation is given. Measurement variation is given. Now how will you find out part-to-part variation?
0.032.
Tell me the formula. Total
Variation minus gauge RR equal to
total variation minus gauge R&R. You have to do small subtraction. The difference between the two will be the answer. All of you are with me this question?
Yes.
Okay. A black belt is developing a failure mode and effect analysis. The following are the rating 3, 2, and 9. What is the RPN number? How to get the RPN number?
severity into concurrence into detection.
Severity into occurrence into detection. 3 into 2 into 9, 54. Okay, this sample size, look at the problem. And this definitely requires, software or some table is required to find out. See here, find the sample size for one sample G test. Given the following, the difference in the mean is 0.5. Population standard deviation is 0.75. Power of test is 0.95. Confidence level is 0.95. All of you, can you remember this? All of
Yes,
you, can you remember this? Yeah.
Yeah.
Now I'm sharing Minitab screen with you. I'm sharing Minitab screen. Now, always when you want to know the sample size for any hypothesis testing, come here, stat. What is the last option?
Power and sample size.
Power and sample size. And now, which is the hypothesis testing we are doing?
One sample test.
One sample set. And now sample size. We don't know sample size. So let us leave this blank. Difference. Difference means difference in the average. How much is the difference in the average?
0.5.
0.5.
0.5. How much is the power value?
0.95.
0.95. Population standard deviation?
0.75.
0.75. Option. Now, significance level. They have told you confidence level. Confidence level is 95%. That means significance level is 0.05. Generally, nothing is mentioned. Two-tailed test, not equal to. Okay. One more time. Okay. And now what do you are getting a power curve. All of you, can you see the power curve?
Yes.
Yes.
To achieve a 95% confidence level and a power of test of 95%, what should be the minimum sample size?
30.
This is the secret behind sample size. If what do you want to do, what do you want to do is very clear, then sample size can be estimated. If the requirement is not very clear, then you have to go for the approximate number, and you can get the perfect number if the requirements are very clear. Here, what do I mean by very clear? The test is one sample G test, and difference in the average is understood. Power of test and confidence level requirements are very clear, and so sample size minimum requirement is 30. If I come down, different say for example, yes, yeah. Keeping the sample size 30, if the difference is keep on decreasing, you see, if the difference is decreasing, can you see the power of test going up?
Yes, sir.
If the difference is decreasing, power of test will be going up. But if the difference is increasing, power of test will go down. So that is what you are observing here. But no worries. Right now, our question is only about sample size. We have solved it. One of you, please guide me how to do that. How to calculate sample size?
Stats, power and sample size.
One
One sample Z.
Feed all the values. Go to option.
Options.
Give the significance level or the confidence level. Any one you should give significance level or confidence level. Now, okay. Then one more. Okay. That's all. Very simple, right?
Yes.
Very good. Now again. I think too many questions are there. Okay, let me go for it fast. Now see here. A hospital wants to determine whether there is a significant difference in the turnaround time. Please tell me, turnaround time, is it a continuous data or discrete data?
Continuous data.
Continue.
And there are 4 laboratories. And you are asked to check whether any of the laboratories turnaround time is significantly different. Now, what is hypothesis testing you should do now?
ANOVA.
And see here, you are supposed to use the data, and then you have to conduct the hypothesis testing and tell whether the difference is significant or not. Because the question is there any significance? So you will say, yes, it is significant when the p-value is less than 0.05. When p-value is more than 0.05, it is not significant, insignificant. So you have to copy, copy the data Where will be the data? Can somebody tell me where the data will be?
The Excel sheet you shared.
In the Excel sheet as a backup, it was given to you. However, no, if the same question comes, then Excel will also be provided there itself. But to avoid the issues, technical issues, some data files are shared well in advance. All of you tell me, do you want me to do it, or you can do it yourself, the ANOVA?
You can show one case in Minitab.
You want me to show, right?
Yes.
Okay, so then I have to first of all take you to the Excel file. Then I should copy the data. Can you see LabTat? Right? LabTat. So I just select all these file data, Control C. Then I stopped, and then again I'm taking you to Minitab now. I'm going to worksheet. I just paste here. Now I'm ready to do ANOVA. Stat. Minute. Stat. ANOVA. One way ANOVA. Separate column. Response. 1, 2, 3, 4. Select. Option.
Options.
Equal variance. 95%. Two-sided. Okay. One more time. Okay. Now p-value. Let us go and check the p-value because the question is about significance. Please tell me how much is the p-value?
0.
0 means less than 0.05 or more than 0.05.
Yes.
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 So what?
Reject null hypothesis.
Question is about significance, right? So difference is significant, that's all. If in the option significant, you must choose that. All of you understand how I did this?
Yes.
Now tell me, for a particular hypothesis testing, alpha equal to 0.05, beta equal to 0.1, what is the power of the test?
0.9.
Right? And for the same situation, what is the confidence level?
0.95.
0.95, right? So if beta equal to 10%, power of test will be 90%. If alpha equal to 5%, confidence level will be 95%. Here what is asked? Power is asked. So answer is B. Find the significance level. Find the significance level when the characteristics value is not allowed in the extreme and beyond 1.5 standard deviation on either side. How many of you understand the question? So I am in Minitab now. Go to stat. Sorry, go to graph.
Graph.
Probability distribution plot. Now view probability. Okay. Nothing wrong. Make it standard. When the practical scenario is not known, assume a standard scenario. Go to shaded area. View probability and choose X value and middle. What are the values they have given? Minus 1.5 on the left side, plus 1.5 on the right side. Now, your company has clearly told any observation beyond 1.5 standard deviation is significant. Your company has told. Now, what is the significance level? Now tell me what is the significance level?
86%.
86% is acceptable, but beyond 1.5 is unacceptable. So what is the rest of the area? 86 is acceptable, means
13.36.
13.36% is the significant area. Can you see 13.36? Can you see 13.36?
Yes, sir.
What is definition of significance? The area beyond the observed value, isn't it? The area beyond the observed value, that is called significance. So now your company has clearly told up to 1.5 standard deviation, don't worry, let it go. But beyond 1.5, it is significant. So beyond 1.5 means the white color area. But what Minitab has given is red color area. If you want white color area, 100 minus red color area. Now, correlation. If the correlation coefficient is 0.9, the percentage of variation in the response variable explained by the variation in the explanatory variable.
81%.
R square, isn't it? So R is 0.9, so R square is 81%. Beautiful. All of you understand? The answer is excellent. Polama, shall we go to next question?
Yes.
The coefficient of correlation between u equal to x and v equal to minus x is, tell me what
Minus-
is the
-1.
minus 1. Very good. Minus 1 is the correct answer. In two-way ANOVA, with one factor at 4 level, another factor at 3 level without replication, what is the total degree of freedom? What is your understanding about total degree of freedom? Total degree of freedom is total number of experiments minus 1. Correct?
11, sir.
Total number of experiments minus
4
1.
into 3 minus
4 into 3 is 12. 12 is the total number of experiment. 12 minus, what happened? Question changed. Okay. 12 minus 1, 11 is the correct answer. Hope you understand?
Yes.
Now, in one way ANOVA with 4 levels of a factor without replication, that means total number of experiment is 4. Because one way ANOVA, only one factor. 4 level. So total how many experiment? 4 experiment because no replication.
3 is answer.
So degree of freedom will be 3. The process excellence team in a bank is inspecting transaction. There are 7 opportunities for error in each transaction. 100 transactions are inspected every day. A number of errors are recorded. Which control chart you will use to study and keep the process in control? Are they talking about defects or talking about defectives?
Defects.
Defects. That means defect, not defective, defects. See here, opportunities means it is defect. So definitely it is C or U, right? And
Question change. Question change. You have to go
question
previous.
change. Sorry, question change. Yeah. And 100 transactions are inspected every day. That means the subgroup size is constant. So we will go for C chart.
So one doubt here, 7 opportunity for error in each transaction. It's not opportunity for failure. It's not defectives.
No, 7 opportunities for error in each transaction. So the definition is in every transaction, there are seven types of defects possible. After the completion of the transaction,
Right.
the name can be spelled out wrongly. The beneficiary name, isn't it? And the amount can be spelled out wrongly. So if anything goes wrong, see, how are you classifying? Only you are going to declare. Right? You are going to declare. If you consider each and everything as a defect, then it is defect only. But defective means complete failure. That's all. But here they look at their language itself clearly says there are 7 opportunities for error. See, for defective means you don't have to talk about opportunities. 100 transaction and 40 transaction failed. Then it is defective. They are clearly pointing out what types of defects happen. So that's why it is defect only. But one thing here is the number of transaction is constant. So we are going for C chart. All right. Now, second one. An inspection process checked parts produced for defectives. Now, the question is about defect or defectives now?
Defectives.
That's all. So you don't have to go through the struggle every time. If somebody is telling clearly it is defect, you just okay. For them, if your client is saying it is a defect, then it is defect only. No need to worry. So inspection process produced for defectives, and the total number of parts produced shift-wise, and the number of defectives were recorded for 24 shifts. Which type of control chart would you use to study the process variation? Tell me. Now it is defectives. Defective means what should be your option?
Chart or
P or NP.
P.
And now every shift they are checking the defectives. Number of units produced per shift. Can it be a constant or can it be a variable?
Variables.
Variable. So what will be the chart? P or NP?
P chart.
P is the correct answer. Very good. Which of the following technique dramatically shortens the changeover time? SMED. Very good. Single minute time. A system that delivers products or services at the correct time and in the correct quantity is referred as.
Just in time.
Just in time.
Correct answer. That's all. Now you are fully ready. All right? Fully ready. All these questions, if you go through one more time, it will be nothing now. But first time, yes, it will be difficult. Right? Because you need to stand out, isn't it? Otherwise, you will also be an average black belt in the market. So please go for that extra mile and try to differentiate you from the average black belts coming from any other source. If you hesitate a lot to do this extra hard work, then you will be joining the average group. Nothing harm will happen. Don't worry. Nothing harm will happen. Clearing the exam is very easy. You all will do it. But then, if you know how to do all this, you will definitely feel fully confident always, because you are equipped with the proper tools. The ideology is clear. Sigma level calculator is there. RKF template is there. And then Minitab is there. And moreover, in the future, we are going to continue the relationship with you. Definitely you can handle the situation. Am I correct or not? All right. So that's it then. Thank you very much. So any question, please ask.